Hey guys, welcome to my channel. So today's video is about the same motor. I've done quite a few videos on it. Those of you that haven't seen them, it's a 6-pole magnet rotor, 2 coils in series with 200 turns each of 18 gauge, and then I have 2 trigger wires on here that I use for the Bedini circuits, but now I just put them in parallel as a secondary winding so that I have isolated output to kind of pulse back into the same battery. And then we're using this nice little lithium titanate battery, 2.3 amp hour, and we got the output going through the cap dump, so we'll be able to see that. And then this is the input amperage, and yeah, with the scope hooked up. So let's start this little thing up. So this is just a single MOSFET circuit with the Bedini style output, but we're not using that on this video. We're using the secondary windings. So yeah, let's give this thing a little spin and what you could do. So if you watch the voltmeter, we get this, we're going to start at about 17%. So you know, obviously that's spinning very slow, but so our input amperage is like very low. We're about 50 milliamps right now, and this is the output. So we're pulsing about a half an amp or so back to the battery. So you see this go down when it pulses. And what's neat is when it's running this slow, like on some of my other videos, you can see the battery just kind of comes back up and then goes down, then goes back up. So this thing could run a really long time on these little 2.5 amp hour. And yeah, pretty neat. So this is 17%, so let's just start bringing her up. You can see the scope over there. So I'm bringing it up to about a 1/4 amp right now. So a 1/4 amp, we're about 70% pulse width, and now you could actually kind of see how it's running. And the return isn't as much, so the battery's starting to go down now a little bit. Because when you have the pulse width at that lowest setting, you get a lot of energy back to the battery. So, and then you can see how the scope has changed a little bit. So we're going to bring this all the way up. So now you can see there's no more pulse width. This is just the waves from the optical timing, and then you can see all the escaped energy at the bottom there. So at full power, we're using about 3/4 amps, and you can see how it's kind of kicking it back down. And so we're 955 RPM, so almost 1,000 RPMs for 3/4 amp at 12 volts. Pretty good. Runs really smooth. So yeah, so this is all even alligator clip together. It works pretty good. You're not getting as much output as you can as you turn down the pulse width. So what we're going to do is turn down this pulse width, and you can hear that sound as soon as that frequency goes. You can see the scope now, and then we're going to start getting more energy back. So now it's kind of compensating, about 50%. We can bring it down even more, down to about a 1/4 amp. And then you can see the battery voltage. It kind of bounces back up. So yeah, pretty neat little motor. It's real smooth, real responsive. See all the difference in the pulse width. As soon as you hear that sound, you can see it chopping everything up. So there you go. Thanks for watching.